Okay, we're looking at number 9 from section 1.5. In this problem, and yours may generate out with a little different numbers, but on this problem, my example, it says that from a point on the ground that's 60 feet from the base of the tree. So we've got some sort of tree, and this is just one way to draw it. You might draw it other ways, but from the base of the tree out 60 foot, we've got a point, and then it goes up to the height of the tree, the distance from this point up to the top of the tree. It says this distance is 4 more than 2 times the height of the tree. So the height of the tree is what we're asked to find. We don't know the height of the tree, so we'll call that distance x as the basic unknown. So we're assuming this makes a right angle, and that's why it kind of fits in our discussion here with the Pythagorean theorem. But you'll have side squared plus side squared equals hypotenuse squared. In the Pythagorean theorem, a squared plus b squared equals c squared. So we can do height of the tree, x squared, plus the other side, 60 squared, equals the hypotenuse, the quantity 2x plus 4 squared. And that will give us something to solve, an equation that's set up. So we can square out what we can. This FOILs out. You can write it twice and FOIL it, or use the squaring pattern to work that. When you FOIL it, the first is 4x squared. The outer is 8x. The inner is 8x. And the last times last is 16. Alright, so it looks like it's going to be a quadratic because we've got the x squareds involved. So I'm going to bring everything to one side equal to 0. It could be to the left side or the right side. I think it looks easier to go to the right side, so whichever way you think looks best, you want it equal to 0. So that gives us minus x squared, 4x squared, and minus 1x squared. You're going to have 3x squared actually. And then we've got the 8x and 8x on that side, which is 16x's. And then this 3600 brought across, I'll put it down here with the constant to combine. What is 16 minus 3600? I need my calculator. It's not going to be a pleasant number there. These numbers didn't generate out, so nice, did they? Let's see. So that is negative 3584. Now what I'm hoping is maybe all of these are divisible by 3. Oh, I know they're not. 16 doesn't divide by 3. But that's always a thought that I have. If you can reduce it, these are difficult numbers to work with, especially if I'm going to try to factor. It's probably factorable if you want to take time to work on that, but that's quite the puzzle. Let's see if I can come up with that. This would be the thought process, though. I think of things that multiply to be 3584. Try different combinations. And I want to try something fairly big, like 2 times 1,000 and something. Obviously, that works, but it's not going to give me a 16 in the middle. I'm going to have to get some pretty extreme values. So maybe 3584. I'm just going to guess. I'm going to divide that by 40. And it does not come out even. So I'm just punching around on my calculator, maybe 44. 3584 divided by 90. I'm just guessing again and hoping to hit something. If this little process wearies me after a while, I will go to the quadratic formula. But that's honestly what I would do for that one. Since I didn't pre-work it out for you, I'm truly just trying to show you what my thoughts would be if I were working this. I did find that 14 times 256 is 3584. So I'm going to go with that. I'm going to put the 256 here. I still think it's way too much. And then times 14. What do I want to do here? I think I'll put minus 14 and plus 256. Okay, so when I FOIL it, the first is 3x squared. The last times last does multiply to be 3584 per my calculator. And then the inner is 256x, and the outer is minus 42x. Not 16x. But, you know, I'm not crazy way off here. I can keep working with this little puzzle. Now that I've got 256, I'm thinking maybe I can build off of that. 256 is 16 times 16. So that tells me that 224 times 16, I could, it just helps me come up with some other numbers that multiply to be that. What else? So I'm going to go back to the drawing board. I'm still going to play with this just a little bit longer before I give up and go to the quadratic formula. 7. See, I kind of like the puzzle myself, so honestly this is what I would do. But if it takes too long, I go to the formula. You hear my buttons pushing there. Okay, I've got another idea. I found that 112 times 32 equals 3584. So I'm going to try that. I'm going to do x minus 32 and 3x plus 112. I have hope for this one. I'm trying to get 16x in the middle. This one failed me, right? So let's mark that out. So starting again, 3x times x is 3x squared. The outer makes negative, let's see, 96x, and the inner is a positive 112x. Oh, that might be 16. I'm hopeful. And then the last times last, I'm just going to double check my work. 112 times 32 equals 3584. And because the signs are different, it is negative. All right, so here's the moment of truth. Is 112x minus 96x, it is 16. So yay! So that's positive 16x in the middle. So that is the correct factorization. Now, like I said, if you hate that, certainly just use the quadratic formula at any point. You would do back to the original quadratic when I got it in standard form. A is 3, B is 16, C is negative 3584. You're going to get some extreme numbers in that quadratic formula, but it will get you there. So doing it by hand, though, with factoring, I would then set each one of these factors equal to 0. This is going to give me a negative solution when I throw the 112 across. So just I can kind of skip that because I'm looking for the height of a tree. So a negative answer for a height of a tree wouldn't make sense. So I can kind of forget about that side. But this side works. So when I throw the 32 over, x is 32. So now I have a viable answer. Back up to my little picture here. If the question is find the height of the tree, there it is, 32. 32, I think we're in feet, 32 feet. I'm going to type it in just to double check before I call this. Okay, check my answer, and it gives me a good job. All right, I hope that helps. That was a good question. That challenged me. You can tell a little bit. So hope that helps.